Hey there, mathematicians. So today we're going to be working with compound inequalities. So compound obviously means more than one. Inequality is an expression with an inequality sign, not an equal sign. So we did some vocabulary before. We're just going to check up on that. A union is a compound inequality uses the word or. So if either part of the inequality is true, then the whole thing is true. Okay, and the graph usually looks like two rays going away from each other. Not always, but this is usually what it looks like. Intersection, just what it sounds like, uses the word and both parts of the inequality must be true. So that usually looks like a line segment connecting two points. Okay? Conjunction is just another word for intersection. Disjunction is just another word for union. So we're going to start with intersections. So they look differently, but this and this are the same. Okay, it just depends on how you wrote it. So if you write it with the word and, you get 2x plus 3 is greater than 3, and 2x plus 3 is less than or equal to 7. The word and tells us it's definitely going to be an intersection. But if you look at this one, we have 3 is less than 2x plus 3 is less than or equal to 7. It's the same thing. You got to be careful. If you're less than the greater number and greater than the smaller number, you're obviously going to meet together in the middle. Now, the nice thing is you solve it exactly the same, just like we have before. So if it's got a plus 3, we know we're going to subtract 3. The thing is, we just need to subtract 3 everywhere. So 3 minus 3 is 0. The inequality sign stays, so we have 2x is equal to 4. Now we want to divide by 2. Remember, if we multiply or divide by a negative, our signs are going to flip. So you got to be careful. 0 divided by 2 is obviously 0. It's less than x is less than or equal to 2. So you can see that this is going to be an open circle. This is going to be a closed circle. Okay, if we solve these, you get the exact same thing. So when you graph it, we know we've got an open circle at 0. We have a closed circle at 2. And if it's going to be less than 2 and greater than 0, it's obviously going to meet here in the middle. Okay? If you're wondering about this, we've just solved this exactly the same. We just solved 2 at the same time. But we already did it over here. The union uses the word or. So if you see it written out, you'll have 3x plus 5 is less than or equal to 2, or 3x plus 5 is greater than 14. The reason I know this is the same as this is because my inequality, the one that I want, the variable, 3x plus 5, is greater than the larger number. So that means it's going to be going to the right. But it is less than the smaller number. So it's going to go to the left. Okay? Again, we're going to solve these exactly the same way. Don't forget, if you do have a negative, the inequality signs will flip. So don't assume that you know what's happening if you haven't looked at the whole thing. So we're going to start with plus 5. We know we're going to subtract 5. Two minus 5 is negative 3. So negative 3 is greater than or equal to 3x is greater than 9. We don't want 3x's, we just want a 1x, so we divide by 3. We're everywhere. Negative 3 divided by 3 is negative 1. The inequality sign did not flip because 3 wasn't negative. And 9 divided by 3 is 3. So I've got a closed circle here at negative 1. I know I've got an open circle here at 3. X is greater than 3, so that arrow goes to the right. This is the tricky part because this is backwards. -1 is greater than or equal to x. So if you read it from the variable though, you see that x is less than or equal to -1, so that's why that's going to the left.